Before we will proceed to the Azure DevOps automation part, I would like to cover one more topic with you. As I was saying before, I am having this design project also to manage my data seeding. So the idea is that if I will use the approach of seeding my initial data with the entity framework, it will basically also handle that data as a part of my migrations, which will mean that as soon as I will generate that script that I was showing to you before, it will also include all that data, and I don't want it. The reason for that is that that script, it consists of the schema of my database, and the schema should be the same across all my environments, starting from my local machine and ending with my production. But the data on all those environments may be completely different. So that is why I want to have a clear separation of schema and data. So basically, to manage my initial data seeding, what I actually have here, let me just show you the program CS file first. So I am creating the context using the database and calling for action migrate, and after that I created that class by myself. I will show it to you in a moment. So data seed orchestrator, and I pass my context there, and then I just call for apply all. So how the thing actually works in the first place. I have everything here. So in data seeds folder, first of all, I have the interface which called iDataSeed pack. The idea is that that's the most simple way of implementing that interface, and that interface basically represents one pack of data that needs to be initialized. So I have two methods here. More or less the approach is the same. We just re-implemented it with our own solution, as I was showing you before with the entity framework migrations in terms of schema creation and stuff like that. So the first method called is present, which will return either true or false, which will basically mean do we need to apply this exact pack of data or not to the current database. And the second method, apply, will actually apply that data if needed. So let's check what I have here in my data seed orchestration. So let's start with the constructor first. I have my constructor, and it receives the database context, and it stores it here. And in addition to that, I have this list of data seed packs. So basically, pack 01, which I will show you in a minute, that's the file, the exact instance of that interface iDataSeed pack. And what I can do here, I can basically add those packs over and over, and I can add any amount of those. And then my apply all method, it basically iterates through all those packages. It checks for each and every package, is it present or not within this database, and if not, it will apply it. Another important part which I also want to highlight is that they will also be executed in that specific order how I put them here. It actually makes sense if, for example, a few different developers actually works on different branches, then they will just add their packs here and they will not interfere with each other. But if you will need to execute some of them in sequence, you will already have that sequence here as a part of the implementation. So let's check my pack 01, what I have here. So this is kind of a super simple thing. So what I'm doing basically, I'm checking the list of my employees, the table of my employees, and I just want to query like any object with the name, any employee with the name Anton Boyko. And if Anton Boyko is not there, then I will understand that I need to add like 4 different employees as a part of that initial seed. So what is important here is that in the current database, the name of the employee, it's not a unique field, but it's required field. So this approach of checking, do we have to apply this pack or not, maybe not ideal. But anyway, the goal was just to show you the approach, and then it's up to you to find a way how to implement it in the best possible way for your project. Of course, you can use the integer primary keys or something like that to make this check more, let's say, viable and more stronger and make it work in a more predictable way. But anyway, as I was saying, my job here was just to show you how it can be implemented. And of course, don't forget to call for save changes to actually save all your changes into the database. And why this is actually important? It's important because this whole project, the backend API data design project, that's the console application, which basically means that I can build that application and I can ship a few different artifacts out of my build process, out of my build pipeline. I can ship as one of the artifacts the API itself, because that's the main part of the project, the application part. Then I can ship, of course, that SQL file, which will be generated automatically by the Entity Framework CLI, as I was showing you before. So we can easily create the schema of the database on our QA, integration, I don't know, security, whatever other environments we may have. And in addition to that, the third artifact, which I will basically publish and share with the entire team, will be this console application. So then I can run this console application. I will show you later how I can pass a connection string to that application. So it will basically seed all the data to that particular database. And in that way, I can have like a full control over my application, over my database schema, and over my initial database data, because that initial data, I may want to apply them, as I was saying, on the lower environments only, like dev, QA, and maybe demo environment, but on a higher environment like stage, pre-prod, prod, DR, whatever, I will not use those. So let's actually switch and check how all the thing is implemented in Azure DevOps pipelines.